So on to section 2.1 on data repositories and 2.2 on comparative studies and proper methodology. So data repositories. In conducting comparative studies, classification researchers and other data miners must be careful not to rely too heavily on stored repositories of data, such as, for example, my aside, muck data sets that have been around literally for decades. Not to rely too heavily on stored repositories of data as its source of problems, because it is difficult to produce major new results using well-studied and widely shared data. And aside from me, I think a different way you could put this rather than major new results is new results that really are in fact results as opposed to incidental findings because you've been banging on this data set for so long. Okay, back to the paper. For example, Fisher's iris data has been around for 60 years and has been used in hundreds, maybe thousands of studies. He gives a number of other examples here. I would guess that we could find similar examples in natural language processing pretty easily. So any new experiments on these and other shared data sets or old shared data sets run the risk of finding quote unquote significant results that are no more than statistical accidents. And he's going to come back in 3.2 and explain to us why in a section related to shared data sets. Note that the repository still serves many useful functions. Among other things, it allows someone with a new algorithmic idea to test its plausibility on known problems. However, it is a mistake to conclude if some differences do show up that a new method is quote unquote significantly better on these data sets. It is very hard, sometimes impossible, to make such an argument in a convincing and statistically correct way. So let's be clear here. He's not saying don't use these old well-known data sets. He's saying they have some real uses, which is, as he says, testing its plausibility. Think about this. If you can't perform well on a data set that people have been performing well on for years, then you probably shouldn't be basing your arguments on performance. You could also point out that, I would point out that from a reviewing point of view or a writing point of view, it's always good to be able to compare to previous literature, and using data sets that have been around for a while is a really good way to optimize comparability to previous literature. But now where he goes from there is, however, it is a mistake to conclude if some differences do show up that a new method is quote unquote significantly better on these data sets. Okay, next section, 2.2, comparative studies and proper methodology. The comparative study, whether it involves classification algorithms or other data extraction techniques, does not usually propose an entirely new method. Most often it proposes changes to one or more known algorithms and uses comparisons to show where and how the changes will improve performance. And so I'll throw in here that these are really, really common in natural language processing, where the quote unquote new innovative approach is pretty much just a comparison of other approaches that we've seen before. So the innovation claim will do something like, nobody has ever done bidirectional long short-term memory with attention and recurrent convolutional neural network along with named entities that were labeled by a CRF as features. Yeah, this is really common in our field, what he says, what he calls not an entirely new method, but rather changes to previous ones. And then of course, you're going to compare to previous methods or baseline or whatever. to show where and how the changes will improve performance. And will improve performance is important there in that most of these papers are basically trying to confirm that they found better performance versus really exploring what makes this work and not work. So although these studies may appear superficially to be quite easy to do, in fact, it requires considerable skill to be successful at both improving known algorithms and designing the experiments. Here I focus on design of experiments, which has been the subject of little concern in the machine learning community until recently. And he gives here a couple of exceptions to that. Some older papers, Kibler and Langley, 1988, and Cohen and Jensen, 1997. And of course, as I read this in the year 2022, there's been other work by people that have made this kind of point. A paper by Walter Dellemans is the recent one that comes to mind, most recent one that comes to mind for me. So back to the paper. Included in the comparative study category are papers that neither introduce a new algorithm nor improve an old one. Instead, they consider one or more known algorithms and conduct experiments on known data sets. They may also include variations on known algorithms. The goal of these papers is ostensibly to highlight the strengths and weaknesses of the algorithms being compared. Although the goal is worthwhile, the approach taken by such papers is sometimes not valid for reasons to be explained below. As an aside here, I think this is, I'll be interested to see where he goes from this. As someone who works in a specialized domain, I'm pretty interested actually in trying out known algorithms on new data sets. I think his point here is going to be that these quote unquote new data sets that you're trying this on are known data sets. So they're ones that have themselves been around for a while. So imagine, for example, if you develop something on the BioCreative 1 data set for named entities that dates back to like 2004, by now it's quite a while ago, and then you're going to test that on Mach4 data, which is even older, to see how it generalizes. Okay.